So let me continue from the 33rd sum in miscellaneous. 33rd sum is 1 to 4 mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3 into dx. So if you look at this sum, you know the intervals are from here it is 1, from here you know the interval is 2, from here you know the interval is 3. The lower limit is 1, which is already written here, so upper limit is 4. So between these limits you are going to check what are the formulas. Between 1 and 2, say an example is 1.5. If you give x as 1.5, it is positive. You give 1.5 here, it will be negative. 1.5 here, it will be negative. So then first one is positive, next one is negative, next one is negative. So then x and x gets cancelled, and this is minus 2 plus 1 is 1. So minus x plus 4 is the new formula. What did I say? 1.5 is an example. Give it everywhere. First one is positive, second one and third one are negative. X minus 1 positive, minus x plus 2, minus x plus 3. So cancel off and write the formula. Okay, between 2 and 3, what is the formula? What is the example? We can give 2.5. The first one will turn out to be positive. The second one will turn out to be positive. The third one will be negative. So that it will be x minus 1. Panite. Done. X minus 1 plus x minus 2 minus x plus 3, because the third one is negative. So x and x get cancelled. So it will be x minus 3. Minus 3 and plus 3 get cancelled. Just an x is the formula. Correct, right? 2.5 we give. First one is positive, second one is positive. So x minus 1 plus x minus 2. The third one is negative, which is minus x plus 3. X and x get cancelled. So it is x minus 3 plus 3. Yeah. Now give another example between 3 and 4, which is 3.5 when all of them are positive. Give 3.5. So x minus 1 plus x minus 2 plus x minus 3, which is 3x minus 6. So 3x minus 6. Thus you have to find the formulas corresponding to that interval, and then you can integrate with 1 to 2 minus x plus 4 into dx, plus 2 to 3 x into dx, plus 3 to 4 3x minus 6 into dx. So this is nothing but you can take 3 out and it will become x minus 2. It will become x minus 2 into dx. So it will be minus x square by 2 plus 4x integrated from 1 to 2 plus x square by 2 integrated from 2 to 3 plus 3 into x square by 2 minus 2x integrated from 3 to 4. So you have something like this. You have an upper limit and lower limit for each and everything. You can substitute and find the answer. So let me do it. Upper limit is the 2. When you substitute in place of x, it will be 2 square. So minus 4 by 2 is minus 2 plus 8. Fully substituted for x. Minus lower limit is minus 1 by 2 plus 4. To solve these two. Now here, what's this? This is 9 by 2 minus 4 by 2, which is just 2, and here plus 3 into 16 by 2, which is 8, minus 4 2s are 8. Oh, both of them get that. So minus lower limit is 9 by 2 minus 6. So this will be 6, this will be 9 by 2 minus 9 by 2. This will be 5 by 2. This will be 3 into minus lower limit, right? So it has to be like this, right? So when I substitute lower limit, minus of lower limit, so it's 9 by 2 minus 6. Okay, like this. So when you take LCM, 6 2s are 12. 9 minus 12 is minus 3. So it's minus 3 by 2, which is plus 3 by 2, which is into, because 3 is common for it, correct? It's come from here. So it will become 9 by 2 therefore. And this, when you solve this, it will be 12 minus 9, again 3 by 2. So then LCM is 2. 5 plus 3, 8, 8 to 16, 17 by 2 is the answer. I hope it's the right answer. Let's check that out. Miscellaneous, chapter 7. Chapter 7, miscellaneous. Which sum is this? Sum number 33. Sum number 33 is 19 by 2. What is the mistake? 8, 8 to 16, 17. That is, it's 19 by 2. So what is the mistake I've made here? This is 6, right? This itself is 6 minus 8, 9 by 2. So it's 12 minus 9. It's just 3 by 2. Yeah, this is 5 by 2. This is, what about this? This is 9 minus 12, which is minus 3, will become plus 3. Plus 3 by 2 will become plus 9 by 2. Yeah, everything looks perfect. And what is the mistake? X square by 2 plus 4x, x square by 2, x square by 2 minus 2x. Upper limit is 4 by 2 minus 2 plus 8 minus lower limit is minus half plus 4. So this is the part, it's minus 1 plus 8. Minus 1 plus 8 is 7 by 2. Okay, and then if you take LCM, 12 minus 7 will be 5 by 2. So when you now take LCM as 2, you get 19 by 2, and that's your answer. Okay, so be careful when you're calculating. So let's go to 34th sum. It's 1 to 3 integration of dx by x square into x plus 1. When I see this, I know I'll take the highest power out. Will it work? No, I don't think so, because it's x square. When I take it out, it will become x cube, and this will be 1 plus 1 by x only. So there's no t dt. So I can't do it that way. Yeah. So the only option left for me is write it as a by x plus b by x square. This is like x plus 1 the whole square. How do you write like that? Plus c by x plus 1. So then LCM will be a into x is already there. One more x into x plus 1 plus b into x square is already there. So x plus 1 plus c into just an x square is equal to 1. So now if you write x is equal to minus 1, this will become 0, this will become 0, this will be c, c is equal to 1. Thus you get c is equal to 1. Next, what do you substitute? You can substitute x as 0. So 1 is equal to 0, the whole thing will become 0, it will be b, that's all. So b is equal to 1. Next, x is equal to plus 1, say I am substituting 1 is equal to a into 2 plus b into 2 plus c. So if you know that b is 1 and c is 1, 1 is equal to 2a plus 2 plus 1, 1 is equal to 2a plus 3, and 2a is equal to 2a is equal to minus 2, and a is equal to minus 1. So once you get all this, you got ABCs, you're going to substitute it directly here. So it's minus 1 by x integration of dx plus b 1 by x square into dx plus c, what is this? C is just 1, so 1 by x plus 1 into dx. So when you integrate this is minus log x, and 1 by x square, 1 by x differentiation is minus 1 by x square. So 1 by x square is minus 1 by x, so minus 1 by x plus log of mod of x plus 1 plus c. But it's definite, I am sorry, this is a definite integral wherein you have to substitute 1 to 3. So you got to substitute 1 to 3. So upper limit is minus log 3 minus 1 by 3 plus log of 4 minus lower limit minus log 1, which itself is 0, minus 1 by 1 plus log 2. Okay, so this itself is 0, and this is log 4 minus log 3, which is log of 4 by 3 minus 1 by 3. Log 1 becomes 0, so it will become plus 1 minus log 2, and log 4 by 3 minus log 2 will become division. Log 4 by 3 divided by 2 is log 2 by 3. and solving these two you get a 3 minus 1, which is 2 by 3 plus 2 by 3, and again there's no c because it's definite, but we are not sure. This is what you need to prove. Wow, oh, I didn't realize this. To show that sum and I got the answer. So that's about it. Let's go to 35th question. This is a peculiar sum wherein highest power will taking out will not help. If you have to take highest power out, then it should have been x dx by x into if it should have been x into x square plus 1, then you can take an x square out, it will become x cube, and 1 plus 1 by x square. So that is the case when that will work, highest power out. It will not work here. You should understand where it will not work. Okay. So the next is 35th question is integration of x into e to the power x into dx. You have to prove it to be equal to 1. 0 to 1, right? Can I try using property 1 minus x? Yeah, Kashyap's property. What would that help? Because it will become 1 minus x into e to the power 1 minus x. Yeah, so I am not getting the same answer for me to add, you see. So x will not get eliminated because it is actually different. So I have to only do isolate. I don't have any other choice. முதல்ல இருக்கிறது அப்படியே இது, ரெண்டாவது இன்டெகிரேட் பண்ண e to the power x minus big integration. First differentiate பண்ண 1, second integration is e to the power x into dx. So x into e to the power x minus e to the power x integrated from 0 to 1. So upper limit is 1 into e to the power 1 minus e to the power 1 is going to be 0 minus 0 into, okay, then minus e to the power 0. E to the power 0 is anyway 1. So can I say the answer itself is 1? Yeah, proved it. So let's go to 36th question. It's minus 1 to 1 x to the power 17 into cos to the power 4x dx. You have to prove this to be equal to 0. The moment it's minus 1 to 1, you see this is an even power, but here it's odd power. So anyway f of minus x will turn out to be minus of f of x. So answer for this is straight away 0. Okay, so property is minus a to a, f of x dx will be equal to 0 if f of minus x equal to minus of f of x. So 37th question, 0 to pi by 2 sine cube x dx. Okay, you can, I have told you it's sine square x into sine x. There is no point in using the first property because it will become cos cube x, and if you are going to add it, it's going to be a minus b, a plus b into a square plus ab plus b square. Let's not do that. Okay, so let's just write it normally and do it as 1 minus cos square x into sin x into dx. T is equal to cos x, the dt itself is minus sin x dx, and this becomes minus dt. Substituting the x as 0, cos 0 is 1, x as pi by 2, it becomes 0. So it becomes 1 to 0, 1 minus t square into minus dt. So it will become 1 to 0, take it inside, it will become t square minus 1 into dt, which will become a t cube by 3 minus t in 1 to 0. Upper limit is 0 by 3 minus 0, ignore, minus lower limit is 1 by 3 minus 1. What is 1 by 3 minus 1? Minus 3 is minus 2 by 3 plus 2 by 3 is the answer. And but you got to prove that this is nothing. Okay, this is 2 by 3 is what you need to prove. Yeah, that's right. Okay, let's go to 38th question. 0 to pi by 4, 2 into tan cube x dx. Tan cube x dx. Okay, it's pi by 4. Can I use tan pi by 4 minus x? But it's not plain, it's not log, nor is it we just write tan square x into tan x and do normally, you know, the basics, just like how you do indefinite. Take the 2 out, write it as tan square x into tan x into dx. You want a secant square x minus 1 into tan x into dx. Taking it in, you get 2 is common, a secant square x into tan x into dx minus integration of tan x into dx. This is t, tan x is t. A secant square x dx will become dt, but however this is definite, which is 0 to pi by 4 and a 0 to pi by 4. So accordingly tan 0 is 0 and tan pi by 4, when x is pi by 4, it just becomes 1. and this becomes a t and a dt, where 2 is common outside, minus integration of tan x we all know is minus log of cos x. So plus log of cos x integrate from 0 to pi by 4. This part has been integrated, the first part isn't. So it's t square by 2 integrated from 0 to 1 plus log of cos x integrated from 0 to pi by 4. So then the 2 is common, upper limit 1 by 2 minus 0 plus upper limit is log of cos pi by 4 minus lower limit is log of cos 0, and cos 0 is 1, but log 1 anyway is 0, so you can ignore this. So it's 2 into 1 by 2 plus log of cos 45 is 1 by root 2. Now you know how you can write this, a division will become subtraction, so log 1 which is 0 minus log root 2. Yeah, so the answer is 2 into 1 by 2. If you can bring the 2 inside, it will be just 1 minus 2 log root 2, and this can go there as a power, right? So root 2, the 1 minus log 2 it will become, and wow, that's what you want. I didn't even see the right hand side. When you do it, you obviously get your answers. A sine inverse of x into dx, you have to prove it to be equal to pi by 2 minus 1. Just write it as sine inverse of x into 1 into dx. I late inverse trigonometry has to come first. Yes, it is already there first. முதல்ல இருக்கிறது அப்படியே இது, ரெண்டாவது இருக்கிறத இன்டகிரேட் பண்ணால் you get x minus முதல்ல இருக்கிறத differentiate பண்ணால் 1 by root of 1 minus x square. The second one has to be integrated, will give you x into dx. This is like t dt, 1 minus x square as t minus 2x into dx will become dt, and x dx here will become minus 1 by 2 into dt. So because of this, this minus is going to become plus. Sine inverse of x into x, or you can write x sine inverse of x into sine inverse of x plus x dx will become dt by 2. So 1 by 2 into dt by root t, and you know root x itself is 1 by 2 root x in differentiation. So 1 by root x, 2 root x is root x, so like that it will be just root t, including the 2 it will just be root t, and x into sine inverse of x plus. And was this definite? Yes, it was 0 to 1. So everywhere you should substitute 0 to 1. And did you change the limits? When it is 0, x is 0, t is 1. When x is 1, t is 0. So the limit here is changed. So it is from 1 to 0 here, and it is from 0 to 1 here. Yeah, here it's always 0 to 1 there, because the t dt has been assumed that changes. Now you just substitute 1 into sine inverse of 1, which is pi by 2, right? Sine inverse of 0 is 0, you can ignore the lower limit, plus 0 root 0 0 minus root 1 is 1, so minus 1. So you get a pi by 2 minus 1, which is what you want. Next is 40th question. Oh, 40th question, sum of limit. That whole exercise has been omitted, okay? That's the 8th exercise. I think it's completely omitted. So next is dx by e to the power x plus e to the power minus x into dx. I've told you, whenever e to the power x is there, either it's e to the power x into f of x plus f dash of x. This is definitely not that format, okay? So if you can get an e to the power x on the numerator, it will be good. You can write this dx by e to the power x plus 1 by e to the power x. So you can simply solve it. You can bring an e to the power x, e to the power 2x plus 1 into dx, so that e to the power x as t, e to the power x into dx will become dt. So it will be dt by 1 plus t square, which is tan inverse of t, which is tan inverse of e to the power x plus c. It's indefinite, so you can leave it like that. So next question is 42nd question, which is cos 2x by a sin x plus cos x the whole square into dx. As soon as you see cos 2x, you can write it as cos square x minus sin square x by a cos x plus sin x the whole square, which is a square minus b square. So a plus b will get cancelled. So you have a cos x minus sin x by a cos x plus sin x into dx. So simply assume denominator as t and find dt. It will be minus sin x plus cos x dx. This itself became dt by t, which is log t, and log of mod of cos x plus sin x plus c is the answer, and that's exactly that's exactly there. So So let's go to 43rd question. The 43rd question is if f of a plus b minus x is equal to f of x, then integration of a to b x into f of x dx is what? Okay. So let's take this a to b x into f of x dx, and this is a property, you know, a plus b minus x. You add it and you can write it as a plus b minus x. So when you use the property, which is the first property, normally it will be 0 to a, when you add it you get a, so you can write a minus x. It's a to b, when you add it it's a plus b minus x, so write a plus b minus x into f of a plus b minus x into dx. If you use the first property, which is 0 to a f of x dx, can be written as 0 to a f of a minus x dx. You get like this. The advantage of this is now you can replace this as f of x itself. So a to b, a plus b minus x into, you can write it as f of x itself. So advantages, this is also I, this is also I, and when you add this equation and this equation, the x part completely gets cancelled. Can you see a minus x f of x and x f of x? So you are left only with an a plus b. So 2i integrate from 0 to 2i is equal to, you will only be left with an a plus b into f of x dx. And a plus b is just a constant, you can take it out, and this 2 you can bring it down, a plus b by 2 integration of a to b f of x dx is what you need to prove, and you have that as the answer there. So 44th question. This is the world's most important sum. It is 0 to 1 tan inverse of 2x minus 1 by 1 plus x minus x square into dx. See, people will think it's linear and quadratic and assume as t dt. So it's the biggest blunder, because this is not a, this is a tan inverse sum. So it can't do t dt within the angle. This is within the angle. So you know how you have to do this sum is tan inverse of, can you write this as x plus x minus 1, the numerator, and write this like a and b, say a plus b, 1 minus ab, 1 minus x into x minus 1, and solve this and see, are you getting this denominator 1 minus x square plus x. Yeah, you got it. Can you see this denominator same? So it's okay to write it like this. How would you know it? You know x plus x minus 1 by 1 minus x into x minus 1, which is by tan inverse of x plus y by 1 minus xy format, which is tan inverse of x plus tan inverse of y. So this itself is tan inverse of x plus tan inverse of y, which will be x minus 1, 0 to 1 and 0 to 1. This sum is a very tricky sum. There is no t dt first of all, because this is within the angle. So you have to manipulate the 2x minus 1 so that you get tan inverse of x plus tan inverse of x minus 1. Now you have to apply the first property only here, That's the part you must very cleverly know. So when you apply the first property, it's tan inverse of 1 minus x minus 1. So this and this get cancelled. Tan inverse of minus x is minus tan inverse of x. So it will be tan inverse of x minus tan inverse of x, 0 to 1, 0 to 1, dx dx. So it's just getting cancelled, becomes 0, the answer is becoming 0. So with this, I have done the last few sums, so damn easy. I would like you to practice till here, and I will cover the first part of the miscellaneous in my next video.